Yeah, that's right, I turned my backpack into a display. Today, I'll be showing you how I pieced this together, as well as some underlying computer science fundamentals. But Wilpo, I don't care about fundamentals or computers, I just want to see the backpack in action. Yes, that's fine, but first, let me show you my haul, and I'll give you the timestamp if you'd rather go straight to the good stuff. So your boy Wilpo is rocking out at Amazon, living that FANG life. Now who doesn't want a good deal? And as an Amazonian, I always want a good bargain. And among the biggest events on Amazon is Prime Day. So, among these boxes, one of them is my experimental backpack. And here it is! So, if you would like to skip ahead to the assembling, here's the timestamp. Otherwise, let's learn about computer science fundamentals, all the way down to the very smallest bit. What is binary? Normally, we learn about computers starting from the bottom, the ones and zeros, but instead, I'll be starting from an example from the top. If we break down the image, it's just a bunch of pixels, where each pixel is a set of numbers that range from 0 to 255. If we go by RGB, our set contains 3 integers for red, green, and blue. It breaks down the channels by each color. You may have seen 255 as a number in your office software or in your image editing software, and that number is no accident. However, 0 is actually where we really start. As you may have noticed, 000 would be black and 255 would be white. This means we have a range of 256 unique integers. If we had a book that had its height, width, and length all at 256 arbitrary units, and we colored each unit on each page with the RGB of the coordinate, that book will be a cube with all possible RGB color combinations. 256 is a special number because that's the range that can be stored in a single byte, which is a unit of memory. Now, you may have heard of binary, which means it's a system based on 2, just like how decimal is a system based on 10. Well, a byte is 8 bits, and a bit is binary, which is either a 1 or a 0, or a true or false. That's because computers work off transistors, which are electrical components, which are in a sense, a binary on-off switch. Since we only have 2 states and 8 slots to toggle, how many combinations can we have? Well, that's simple. It's 2 to the power of 8, which is 256. So, with 1s and 0s as fundamental building blocks of computers, this is a perfect example of how we bridged the final product down to the binary. Now with the mini lecture out of the way, how does this backpack actually work? To start, we'll need our image frames, which will be strung together to create the illusion of motion via animation. And well, for anything electrical, you'll need power, so we'll need to slide in a power source, which in my case is a solar-powered battery, which we'll connect via USB that feeds into the display. The battery can fold itself up, which means it can be stored within the backpack itself and reside comfortably inside when we zip it up. Next, we connect the backpack via Wi-Fi and send over our image asset wirelessly. I've set mine up to loop infinitely. Once the configuration is completed, all the data is stored locally on the backpack, and it's good to go so long as there's current flowing through the nodes. Now, what other image could I slap onto this bad boy?